Good evening, everyone. Welcome to the last talk of the third day of the Mobius conference, and I believe this will be the last talk of the conference. So, a great way to finish it. My name is Vladimir Ivanov, and I'm happy to announce that this talk will be conducted by Joe Birch, a senior engineer at Buffer. And his talk will be about accessibility with Jetpack Compose, essentially Jetpack Compose for everybody. But before we start, we would like to, talk a little bit. So, Joe, how's the weather in Great Britain?
Hey, yeah, it's pretty gloomy today. We're coming into winter now, and it's super cold, and yeah, it's not very nice. How's it where you
Okay.
are?
Okay. Today we had snow,
Oh,
but it's like +6 here, so all the snow went away immediately. Do you have snow already?
not yet, no. So I can't complain too much, really.
Okay, so you don't like snow.
No, no, I don't. It's too cold. Let's
Okay.
just say we don't have snow here, so it sounds like it's colder where you are.
Okay, okay. And what about all this Christmas mood? Snow, Christmas trees. You know,
Ah, I enjoy Christmas, but we're still in November, so for me, it's like it's too soon.
a bit
Yeah,
premature. Yeah.
yeah, maybe in like 3 weeks' time. But
Okay, okay, okay. Good. So yeah, and I know the weather is not that great, so we're all at home. How do you feel about doing the conferences online? Like, how do you compare it to the offline experience? Do you have any pros, cons, something like that?
Yeah, that's a good one. I kind of like, yeah, pros and cons of both. Like I love going to in-person conferences. I love talking to people face to face and being on the stage and having like the good the professional setup. But I think there's something nice about giving the talks from home and being able. I think they're so much more accessible. Like it's kind of related to this talk. Like you don't anyone can give a talk from home, anyone can watch a talk from home, and anyone can be involved. I know you lose out on that face to face, like real life experience, but I think that kind of accessible aspect is really important and just helps to bring more people together in a remote fashion.
Yeah, that's why we try to build the platform so that it allows for chatting, video engagements, and so on. So yeah, making it more accessible. Thank you. Okay, talking about accessibility, how you got inspired talking about accessibility in particular?
Yes, good one. So I have some conditions that run in my family. It's like my mother and my grandmother have genetic eye conditions that eventually lead to blindness. And as I started to understand how serious those conditions were, I became more and more interested in like the things we build. Like I was already working in tech at the time, and I was like, well, how's everyone going to be able to experience the things I'm building, and how do these things feel when people who maybe have certain disabilities engage with them. So I just kind of became interested in how that all works and what it looks like for people and started playing around and trying to learn more about it.
Uh, yeah, that's a great source of inspiration to help other people, having better experience.
Mm.
That's great. Thank you very much. I think we can proceed to the presentation itself. So, folks, get prepared. We're starting.
Great. So yeah, thanks for being here today. As I mentioned, my name's Joe and I'm here to talk about Jetpack Compose and accessibility. So, but first, I want to take a step back from technology and from technical content itself. I think unintentionally, it's easy for us to become isolated from others around us. You know, life is busy and it's easy to get caught up in our own things. We can often forget or not even think about the things we're doing and what they might look like for someone else. For example, how you get to a conference. Say if you were blind, maybe deaf, or even had some form of physical disability, how might that have looked different for you? That could be include getting to a public transport station, crossing a road safely, knowing that there's no traffic coming, and even the things you do on those journeys or these day-to-day tasks could look very different for someone else. And while people manage to do these things, we know that they might not always be simple. There may be hurdles that people experience and obstacles that come in the way. So, being in this bubble, it may come as a surprise to some people to hear that 15% of the world's population has some form of disability. That is equal to about 1 billion people. And whilst that is kind of vague, seeing as there are so many different kinds of disabilities, it's quite a high number. And a lot of disabilities are actually age-linked. So as the years go by, this number is bound to rise in a linear fashion unless we have some form of medical breakthrough. This statistic is actually validated by the fact that only 17% of people with disabilities are actually born with them. So that's a pretty low number. Going to a local number in the UK, 83% of the 11 million people in the UK with disabilities developed them after they were born. So it's far more common in this case to experience a disability at some time in your life rather than being born with it. And that's something that actually really surprised me at first, and not trying to scaremonger people, but it's an interesting way to see it. And when it comes to these disabilities, there's actually a lot of things that can have a lot of crossover. So for example, one thing that may help someone who may be blind may also help someone who has some form of cognitive disability. So with that in mind, what can we do about this when we are building apps with Jetpack Compose? We'll come on to the practical side of things shortly, but first we're going to take a look at how things are working under the hood. So the key concept when we come to accessibility in Jetpack Compose is semantics. We're going to be hearing a lot about semantics over the coming slides, so it's important for us to understand exactly what these are. So when working with the view-based UI toolkit in Android, the views that we have are clearly defined. We have some form of rectangular space that a view occupies, along with the various properties that that view holds. Now, when it comes to composables, our UI is emitted into the UI hierarchy, and at that point, we rely on semantics for these services to be able to understand the UI that we are working with. So when it comes to the use of composables to build apps with Jetpack Compose, composition provides the description for the composables within our user interface. These composables are then run to produce the representation of this UI. We can view this representation as a tree-like structure that describes how our user interface is going to be drawn. However, this isn't the only tree representation that exists. Alongside this description of our composition, there is also a tree that represents the semantic meanings of our composables. These are two very different concepts. So the composition tree describes how our UI is to be composed, as in how it's going to be drawn on screen. And then the semantics tree, on the other hand, describes the semantic meaning of these composables, giving meaning to each component that is being represented in the side of our UI. But why does this matter? So when it comes to accessibility services and testing frameworks within Android, knowing how our composables are being drawn is not too useful for these. Accessibility services need to describe the content of the components to users. So describing how the composable is being drawn is not going to provide enough information to aid the users of our apps. So for testing frameworks, again, there will not be enough information to effectively test our composables. So instead, these services need to know more specific details about these composables. This could be a textual value that is being displayed to the user, or some form of description that describes a visual component within our composable. This way, these services can look at that description of our composables and portray this effectively to the user, as well as providing a way for developers to perform assertions and interactions with specific components within tests. Now, the good news is that in a lot of cases, semantic meaning will be automatically applied for us when we are using certain composables. For example, if we use a text composable to display some text to the user, this will be represented by the text semantic property. This text becomes how this composable is also described via semantics. This means that when a screen reader is focused on this composable, this description will be read to the user to describe the given content. In a similar fashion, from the Compose testing framework, we can use this description to locate a given node in our composable tree. Once the node has been located using this description, we can then perform any assertions and interactions on it. Now, without this description, it would reduce the usability of our app when accessibility features are enabled. It would also be difficult for us to locate these within the testing framework. So while composables will populate these for you, in some cases, you will need to manually provide your own descriptions. So for example, in the case of using visual composables, such as the icon or the image, if the visual representation of this adds information that aids the experience of our UI, the screen reader will not be able to describe these elements without that description. And the same goes for custom composables or lower level drawing on the canvas. If you do not provide descriptions that will be used to populate the semantics tree, then the accessibility services will not be able to describe your apps to users. And from a testing perspective, you will also experience difficulty when trying to automate the testing of these composables. Now, for a lot of composables, semantics will automatically be inferred from the composable definitions. So if we have a composable that has some text, then Talkback will be able to use that. The same goes for buttons that are disabled or checkboxes that are checked, and so on. However, in a lot of cases, there are composables that won't have sufficient semantics to describe elements to users, as well as there being opportunities to build on the default semantics that we can provide even better semantic experience for users using Talkback. And this is where we come in. As developers, there are points we can intervene to improve the accessibility of our composables. So now that we have an understanding of how things are working under the hood, we can move on to learning about some of the approaches that we can take to make our composables accessible to users. We'll work through a collection of examples where accessibility can be hindered, allowing us to see how Talkback operates, as well as how we can solve these issues when it comes to Jetpack Compose. So the first thing that I want to take a look at here are touch targets. We need to ensure that any composables that can be interacted with have a big enough area that can be touched. I'm sure we've all interacted with a UI component that has a small touch area or attempted to use our phones on a bumpy car journey. Having big enough touch targets helps to ensure that our components are interactable by the user. So when I first started looking into semantics, this was actually something I overlooked because it's something that we control via compose modifiers rather than needing to modify semantics in any way. So let's take a look at this composable as an example. We have an icon that we have applied the click modifier to so that we can listen for click events. When it comes to the visual representation of this, we can see that the touch area only wraps the size of our icon, and our icon does not meet the minimum requirements to ensure that this composable is accessible. Clickable elements should have a width and height of at least 48 dp to ensure that they are accessible to the user. Without this, users may encounter friction when trying to trigger events on UI components. So what we can do here is utilize sizing modifiers so that the clickable composable has a size that meets the minimum requirements for an interactable touch area. We can use minimum size modifiers or static size modifiers to adhere to this, depending on the content that we are displaying. We can also mix this with padding to increase the area of our composable. It's important to apply the padding between any size and clickable modifiers, as this is to ensure that the padding is added to the size of the composable while still ensuring that the whole composable remains clickable. So with this in place, and we can see in the visual representation that our composable now has an increased touch area, reducing the friction that users would encounter when trying to interact with our composable. So while this works, there are actually ways which we can achieve this with much less effort, using some of the built-in elements of Compose that are already on offer. So in the case of our icon, we actually have access to what is known as an icon button composable. So this composable takes a click listener and a content argument, and being a button, this composable is designed for user interaction, meaning that by default, it will have the minimum required sizing for a touchable component. This means that we won't need to apply any sizing or padding, as the composable already has that configured. Now, if we look at the visual representation for this, we can see that this gives us the same result as previously, except with reduced effort from our side. So with that in mind, it's important for us to default to using predefined components, especially from the material library, if what we need is already available from the framework. So to recap on our touch targets here, we need to ensure that all composables can be interacted with via touch events have a minimum area of at least 48 dp. And remember, you can use a mixture of sizing and padding modifiers to achieve this. So while that is possible, though, it's important to also lean into existing implementations of composables where available, such as composables that are provided through the material APIs. This avoids us having to recreate the wheel for accessible implementations. Another example of the icon and icon button is using a text button instead of a text composable. If you're using click events on a piece of text, then using the text button makes much more sense. So when possible, avoid sacrificing these minimum touch targets based off of designs that are provided to you. In fact, this is a great opportunity for you to pass on feedback to your designers and educate about any requirements when it comes to accessibility of the designs that are being passed on. And if you are using material components that provide these requirements by default, be aware of any overriding of the touch targets and sizings, as this will break the accessibility requirements that are already being met by the composables. So when UI components are touched or navigated to, and Talkback is enabled, these click events won't be triggered right away. Instead, the composable will come into focus for the accessibility services. When this happens, some composables will rely on descriptions to have their meaning portrayed to users, and it is our responsibility to provide that meaning. So let's say we have this composable, an icon. This could be an image that we load from a URL or a local resource. No matter the source, it is a visual element. These composables all require a content description argument to be provided for them. However, this is a nullable argument, so we could technically just pass null for this, right? Let's see how Talkback behaves when we set this to null. As we can see,
Settings.
the icon comes into focus via the accessibility services,
Settings.
but there is no description. So as a Talkback user, I have no idea what the purpose of this icon is. Is it portraying some kind of meaning? Am I missing out on some kind of context here? Without this description, we can see how experience here could be hindered. So instead, what we'll do is we'll provide a description to this argument. We'll grab a string from our resources that portrays the meaning for this element and assign it to the content description argument. How does Talkback portray this now?
Settings. Close settings screen, image.
So with this applied,
Settings.
Talkback is able to portray the meaning of this visual element to the user. There's no guessing what this might be or frustration from missing context. We've provided this description so Talkback is able to effectively communicate these things for us. So aside from this, we might also be working with composables that do not have this content description argument. In these cases, we can use the Semantics modifier to manually set a content description for a composable. This will be useful in cases where you're doing some form of custom drawing, such as using the canvas, and you need to portray meaning for a visual element that is being composed within your UI. So when it comes to these content descriptions, use them to provide meaningful descriptions for composables, allowing accessibility services to provide meaning to visual elements that are being displayed on screen. And remember, it's okay to mark content descriptions as null if there is no need to provide meaning for a composable. This is usually when the composable is for decorative purposes only. Now, in a lot of cases, we are required to provide some form of value for a content description, even if it is just null. It's important not to just default to applying null to stop the compiler from complaining and telling ourselves that we will do this later. This is something I'm definitely guilty with within the Android UI framework, to ignore the linting errors. So Jetpack Compose sets us up with a bit more success here. So it's important to avoid doing that by default. And at the same time, remember that not everything will require content descriptions. They are there to add meaning, which some things such as purely decorative components do not need. So alongside content being described, there are further types of descriptions that we can provide in Jetpack Compose. So for composables that are clickable, we can provide what is known as a click label. Now, this is not visible within the UI or to the user, but if Talkback is being used, then where a click action is available, the click label will be used to describe the purpose of that click action to the user through the Talkback services. So when implementing a clickable modifier in Jetpack Compose, we're likely going to see things that look like this. We have some composable that we want to enable click events for, so we apply the click modifier and then handle the click event for that composable. So when it comes to Talkback, this is what we're going to see communicated to the user.
Item 1, lorem ipsum dollar sit armet. Double tap to activate.
You can see here that while this is communicated
lorem
that
ipsum
there
dollar
is
sit
still
armet.
interaction available,
Double tap to
there's no
activate.
clear indication about what that interaction will be. Will it be a terminating action? Should I click it to find out? And we can see here how this might cause some friction to the user. So what we can do here to improve this is provide an on-click label, which will be used to communicate to the user what the purpose of the click action is. This takes a string, so we can provide this in the same way that we would for a content description. This would then be portrayed to our user like so.
Item 1, lorem ipsum dollar sit armet. Double tap to open item 1 article.
We can see now that Talkback can clearly communicate what the click action will do, allowing the user to really understand the purpose of that action and what it will result in. This removes any friction that might have been experienced previously or any confusion around what click events might trigger. So we can see that we can use click labels to provide interaction descriptions for users for the composables that has an action available. Now, click actions and content descriptions will serve different purposes. Content descriptions describe the content, click labels describe the action. In a lot of cases, these will be read out together, so be sure that they complement one another and are not just repetitions of the same content. You should also rely on content descriptions to describe the content, the action for a piece of content. The click labels are there for a purpose and what the user relies on for action descriptions, so we should be using those labels to describe that. And the same goes for modification of other semantic values. If you are describing a click action, use the click label to do so and don't rely on other semantic values. Talking of these other semantics, this is a good segue into text semantics. So while click labels are used to describe the actions that can be performed for a click event, the text semantic allows us to control the text that is used to describe a composable. So let's take an example. We have a text composable that is displaying some kind of text to the user. And in a lot of situations, we won't actually want to apply any modifications to the text that is being displayed. However, with this specific example, we have an example of P/M. So when in the UK, a lot of people read this as per month. Other places might read it as per meter. Thing is, this text does not have any context around what that is being used for. If I was to show this inside of a rental app, so for a property rental, I would expect this to say £60 per month. It's a cheap piece of property, but that's what we'd expect it to read. However, if we take a look at how Talkback will read this to the user, it's not super clear.
£60 per meter.
As we can see here, this isn't correct. This could be the same for per month, per annum, centimeters, or any other kind of abbreviation that we might have in our application. And this is because Talkback doesn't have any context around what that text is being used for. It's literally taking it and translating it in what it thinks it means. But what can we do here? And how can we make it so that the screen reader can describe this without having to change the visual content inside of our app? In these cases, we can use the text semantic property. Now, this is not what is used to describe a piece of content, but it is actually the property that the accessibility service will use as the representation of that content. What we can do here is provide a value that is used to override the semantics of our composable, meaning that this new text property will be used by the accessibility services for the representation of this textual content. So with this text semantic in place, we can now see that the original text content
per month
of this composable is still in place, but Talkback is reading something different. It's reading the content that we provided via the text semantic while keeping the visuals in place that was originally being provided to it. So from this example, we can see that the use of text semantics can be done to improve the representation of text that is being composed in our UI. We are essentially changing the spoken representation of that composable without modifying how it is being represented inside of our UI. Now, because we have this text semantic, it's important to override it where applicable and not use other semantic properties to provide an alternative semantic value. Overriding the text semantic will replace the existing semantic value, so we'll avoid any values being represented multiple times. On that note also, the text semantics are not something that we should really need to override often. While they can be used to simplify textual content, as well as add clarity to it, it's not something that we should need to use regularly to override any composition. So with the examples of these semantic values, we've been able to see how Talkback will navigate through the different composables in our hierarchy. Now, you may be thinking, that seems like a lot of navigation. And this is where what is known as merging descendants comes in handy. But why exactly would we want to merge descendants, and what does that even mean? So let's take a look at an example. The content here isn't exactly relevant, but let's imagine we have a composable tree that is representative of the structure we see here on screen. We have a column that contains a row with 2 child composables along with a text composable. When we come to Talkback, we were going to see that every child in this composable is going to be focused. That means that the user needs to navigate through each of the focusable items that are being shown.
You've won. The 28th of June. Thanks for entering our competition. We're excited. Coffee.
So here, if we're trying to navigate through a list of emails, that navigation becomes a little tricky because we can see there that we have to navigate through 3 focusable items for every single email in that list. That means it could take the user a lot of time to get to the 6th email in their inbox. We want to remove this friction when using Talkback so we can utilize semantic merging to reduce the number of focusable elements that are being shown within a composable. So when it comes to the composable code, this is actually a very minimal change that is required. When we use the semantics modifier, we can provide a flag which is used to indicate whether we want to merge the descendants of this composable. So this will default to false. So if you don't provide a flag for this, it will not automatically merge descendants, but you can override this by passing in the true value. So when we have this applied,
You've won the 28th of June. Thanks for entering our competition. With coffee, the 1st of April was.
So here we've merged the descendants and now the whole column is being recognized as a single descendant. Talkback will now read the title, data, and description as a part of the representation of a single composable in one go. This now also means that it's much easier for the user to navigate through the list of emails as the list is made up of single focusable elements, rather than each email having 3 focus points. Now, this will really depend on the content that you're displaying. So if, say, each of these emails had a massive paragraph for each of the descriptions, it wouldn't make sense for us to read the entire content to the user. So while they could skip the content by focusing to the next item, it only makes sense for us to merge this when we need to. So we've seen here how we can use the merge descendants flag to compress multiple semantics into a single representation. This not only helps to remove bloat from the semantics tree, but it makes our UI much easier to move through when we are being used by the accessibility services. However, navigation should not be a sole reason why we merge descendants. It should be strictly done when multiple descriptions are not required for the same area. If it makes logical sense for components to be traversed through and described on an individual basis, then they should be kept that way. So merge descendants, again, is probably not something we're going to use all the time, but it's something we're going to selectively use when we feel it's appropriate to simplify the semantics tree for the user. So alongside these semantics modifications, we can also provide a description which is used to describe state. For components that have a dynamic state that can be controlled, this allows us to add clarity to the state of a component and describe the state that is currently being represented, rather than relying on a visual representation of that. So let's take this example in the form of a toggleable component. We have a custom switch composable that can be toggled between on and off. We can see this being manipulated here via some flag. But how does Talkback communicate this to the user?
Switch. On. Off. On.
So we can see here that nothing's being clearly read to the user. It's not super clear what state the current is related to. And while we can focus on the whole row again to hear the semantic description, there are things that we can do to add clarity to the state of our switch. So what we can do here is we can utilize the state description semantic to provide some meaning to the current value of our state representation. So here in my composable, I am now building a string based on the current value of the enabled flag, followed by assigning this to the state description semantic property. So this description is being applied to the value of the state description, and then this will be read out by Talkback and communicated to the user.
Notifications are enabled. Notifications are disabled.
So now, rather than the user just hearing on, off, or disabled, enabled, the user has full context on what is happening with the state change and what that row currently represents in form of state. This avoids the user having to kind of play any guesswork and removes any friction that might be involved when it comes to the current state of our composables. So from this example, we've seen that we can use state descriptions to add context to the current representation of the state, allowing us to expand on a simple status of a component, helping our users to understand the current state quicker. So with that said, state descriptions should only be used for what they are designed for. State descriptions. We shouldn't use these to instruct our user on possible actions that can be triggered or any other kind of descriptions. Keep them for state descriptions only and utilize other semantic values where appropriate. So talking about switches brings us onto switch accessibility. And in fact, the accessibility aspects for any other kind of toggle components, such as checkboxes, radio buttons, and so on. Any component that can be toggled between different states by the user. So what's up with these when it comes to accessibility? Let's take a look at an example of a switch composable and how this might currently be represented. So we have nothing special here. We are composing a text label along with a switch that can be used to toggle a state value. So when it comes to how Talkback will represent this composable, we're going to see something like the following.
Enable notifications. Off. Switch.
We can see here that the label and switch components are represented by individual elements. There are two key issues here. The user would hear the label description and then nothing else, and we are kind of expecting that they would move to the next item to get more context, which we should really be providing up front. The second issue that is only the toggleable component is toggleable. So this means that the user needs to navigate to each component individually in order to control that toggle state. We can actually improve this here by
Enable notifications.
By making the row that contains our child toggleable component toggleable. So this means that the parent row now holds, manipulates, and communicates that state of our component to the user rather than the switch being responsible for that. This means that the user now interacts with the role as a whole rather than that individual switch component. So when it comes to the Talkback experience of this, utilizing the toggleable modifier, we can now see that the Talkback is able to communicate things via the row.
Notifications are enabled. Notifications are disabled. Notifications are enabled.
So here we can see that the whole row is now clickable, and this not only means that we can now interact with the row as a toggleable component, but also reduce the number of navigation steps that are required to move through our UI. And this is not only for accessibility services, but also for users that don't even have Talkback enabled. There's so many apps that I use that don't do this. Like I always try and click the row and expect it to toggle something, and it doesn't. So this is just a general user experience improvement that you can make in your apps anyway. So we can see from this example that we can simplify the experience for toggle components by lifting that toggle state up into the parent container. This simplifies navigation for our UI and also any interaction that takes place for these components. So setting the role semantic is something that is automatically done for switch composables. But when you're using the toggle modifier, we have to do this ourselves. So this is used by the accessibility services to be aware of what the component is and communicate it to the user. So remember to set this when you're using these custom containers. So when it comes to these kind of interactions with components, executing a single action is not complicated. It's not complicated to communicate, and it's not complicated to execute. However, there are cases in our UI where there are multiple actions that might be executed, or those actions aren't clearly represented within our UI. In these cases, the accessibility APIs provide us with what are known as accessibility actions. And this is a native accessibility API that is already baked into existing Android apps where available. So let's take a look at an example. We have a list of items, each represented by a clickable column. Clicking the column will launch a screen to read more items about the email, but there's also an icon that can be used to delete the email. You might also have more actions here. Maybe another icon does something else, or there's a button, or there's even some actions that require the user to swipe the card to perform that action. With this composable in mind, let's take a look at how Talkback might communicate this to the user.
Item 1. This is the first item in the list. Double tap to read email. Delete email.
So we can see here that the user needs to navigate through each items in our composable, listening to the description every one. So this is just the first item, but the user will need to navigate to the second item and then each action in there. This could be very time consuming. And like I mentioned before, if we have multiple actions for each card, this is going to get very, very long. So instead, we can utilize what are known as accessibility actions. These allow us to provide access to these available actions with greatly reduced friction and in a native fashion that Talkback users will be familiar with. So let's see how Talkback will handle this when we are using accessibility actions in our apps.
Item 2. This is the second item in the list. Talkback menu. Actions. Read email in list.
So we can see here that now the actions for our list are accessible through the native accessibility actions route, which is a user experience that Talkback users will be familiar with. This also reduces the number of navigational steps that we need to take when navigating through our items. So we've seen here that we can use accessibility actions to provide a native experience for Talkback users to trigger content actions. It's important to provide these in your apps where actions are available, as it's something that Talkback users will likely expect to be there when using your apps. As well as being aware that this does not mean, as well as being aware of this, it's important not to disregard accessibility for the UI components that do trigger actions. So for things like content descriptions and so on, and click labels, it's important to still provide these just in case you are a user who is not using these actions. So you're providing different accessible routes for different people. So on the topic of reducing navigation via actions, there is also a feature in Talkback that allows users to control how a screen is navigated through. One of these ways is via headings. So if a screen has content that is separating to headings, the screen can be navigated through via sections rather than individual components. So let's see how this might affect our user interface. So here we have a simple text composable that is displaying some title of a section in our screen. It's likely that we'll have multiple sections that are styled like this, but without the use of headings, we would see something like this when using Talkback.
Learn Jetpack Compose. Lorem ipsum dolus. What is Jetpack Compose?
The user is needing
Lorem
to
ipsum
navigate
dolus.
through each
Let's learn about state.
If our screen had a lot of UI components and not everything was a paragraph and simple text composable, say there were images and other things, this could get pretty lengthy for the users to navigate through. However, we can utilize the semantics again to mark certain composables as headings. With this semantics modifier in place and the heading declaration, Talkback will recognize these components as headings for the different sections of our user interface. So if we take a look at how Talkback would render this.
Learn Jetpack Compose, heading. What is Jetpack Compose? Let's learn about state.
So we can see here that using certain swipes that, again, Talkback users are familiar with, the user can navigate through our UI using these headings, using composables that are marked as headings, resulting in a much quicker navigation for our screens without the need to focus on every single component. So here we've been able to see that we can use headings to break up our content into different sections, again, reducing the friction for our users who have Talkback enabled. So with the ability to do this, it's important to be aware of how we can break our content up in such a way. So while we saw simple text in this example, your UI could look different from this, and they could be represented by multiple composables, but still have some form of heading representation. So when you are creating content in your apps, think about how you might be able to split it up to be able to mark things into section components. So if your content is not broken up into sections and does not have headings, do not use heading semantics, as you'll likely cause more confusion to users rather than helpfulness. And finally, don't use headings for visual decorations. This would again cause confusion and result in the user navigating through the screen and not being able to tell where they are. So at this point, we've covered a lot of concepts around semantics and simplifying navigation through Talkback. So I want to finish up on one more thing, custom composables. So it's likely that in our projects, we're going to be creating custom layouts in Compose and other things using the canvas. In these cases, we will often have a blank slate when it comes to semantics. So we need to be even more aware of providing context and content for our composables. So let's take the case of building our own checkmark component. We might have a row that shows an icon on text, where styling of these depends on some kind of flag. This allows the user to toggle the composable both on and off. If we are going to be doing things like this, we need to think about how these components are portrayed by accessibility services. While for a user not interacting with Talkback would just click on this item and not know any different, Talkback uses the semantics to provide context on what the composable is. So instead of using this clickable modifier, we're going to use the toggleable modifier to build a custom component that represents its purpose. What we've built is a custom toggle component, so you should be using the modifier that is built for that. This way, Talkback knows that it is a toggle component, and that can be communicated to the user where appropriate. So another example of custom components might be scenarios where we're using the canvas. In these cases, we have a blank slate again. So because we are drawing custom shapes on the canvas, these are going to have no form of semantic representation. And in these cases, we're going to want to ensure that we are composing what can be described to users. So when it comes to this, we would still use the approaches that we've learned throughout this talk to apply semantics to our composables. We can use a content description to describe the role of the item that we're drawing, as well as set the click label. And then we can simply use other things we've learned to apply these directly to the canvas. It works in no other way. We use what is available from the API. So with all that in mind, we now have a good handful of knowledge around making composables accessible. This isn't an extensive collection, but is enough to help improve how our apps are experienced. So as an engineer, I would highly encourage you to try using Talkback on your device, learn how it works and how your app behaves with it. Once you understand how Talkback works, it can really open your eyes as to how these things will operate when working on your app. This is really helpful for understanding where your app falls short in terms of accessibility, allowing us to create better experiences for all of our users. If you're looking to learn more about accessibility and Jetpack Compose, I would highly recommend checking out these resources. There's the Google Code Lab on Jetpack Compose accessibility. We also have some blog posts over on Compose Academy, as well as these 2 blog posts at the bottom, which are really good on helping to understand best practices when it comes to accessibility in Compose, as well as semantics. So I'd highly recommend checking out any of these. And if you're looking to learn more about Jetpack Compose, in a couple of weeks, I'll be launching this project book, which is a practical approach to building apps with Jetpack Compose, which covers various topics, and accessibility is also a big focus for the projects in there. So if you're looking to learn Jetpack Compose, I'd love for you to sign up on the waitlist on this link. With that said, that's it from my side. So I think I wanted to share today. So I hope you enjoyed it, and I hope you've been able to take away something from this session. Thanks for watching.